Hello, it's very nice to be here. Thanks for having us. So we're going to try to split this between the two of us and let's see how it goes. And it's called Tales of Automated Feedback in R and Python. And I want to start by saying we're talking about automated feedback, which sometimes also means grading, but not necessarily. So as we're going to be, for this talk, we're kind of assuming that you know a little bit of R or Python and/or Python and you teach with them, and that we're also assuming that you're familiar with our Markdown and/or Jupyter notebooks, and either have taught with them or at least have considered talking with them. If this does not necessarily define you, I think there's still going to be a lot of good takeaway lessons, but some of the technology might feel unfamiliar, and we'll try to kind of address those as we go along, and if not, we can obviously handle that at the end in the Q&A as well. So let's start with the what and why when we say automated feedback. So there are two main reasons that automated feedback can be helpful. One of them is nudging, that is nudging the students towards the right answer, especially helpful in formative assessments. And the other one is scaling. It allows you to scale up the efficiency of grading faster than human resources. So let me give you two examples along the lines of these. So let's take a look at this very simple question. I tried to pick one where the code would just fit on the screen. Suppose 10 means from a simulated sampling distribution is stored in a vector called means. So if I were to say to R, report back to me what's in this vector, it'll spit out these 10 values. And then let's say that we're asking students to get what is the value of the first mean. And let's say that a student tries this. They say mean, and I want in square brackets the first element of it, and R says object of type closure is not subsettable, and your student is probably thinking object of type what now? It's really not clear what that's saying. But instead, if instead of that feedback, that also is a piece of feedback, but it's not a really useful one, at least not for beginners. What if we said something like, we were actually give informative feedback saying mean is a function, and function doesn't have elements that can be subsetted with square brackets. That's what that gibberish means. Means is the vector of sample means you calculated earlier. That will really nudge your student to the right answer. Another sample question. Let's say we're visualizing the relationship between city and highway mileage of cars from the MPG dataset, conditional on year of manufacture. And let's say that your student gave you a visualization like this. And they said there's a strong positive linear relationship, and here is my visualization. And let's say that you're going to start giving some feedback on this. There's actually a lot you can say. You mentioned a linear relationship, but you actually did not fit a linear line. You didn't really use the right aesthetic. You might talk about the styling of the plot or the code. So much to say, but so little time for such a simple question. So some of this sort of feedback could actually be automated to save you time. So our courses are growing, and that is a good thing, right? But maybe if they're turning in their work as our Markdown documents, that makes collecting submissions, including code and narrative, straightforward. But providing feedback on both the code and the narrative is not scalable unless human resources dedicated to your course actually grow proportionally with enrollments, which, if that's true for you, please let me know where you work. So what are some of the options we have for giving automated feedback in R and Python? I'm going to start with the first option, the LaurenR and Greatest duo. So what do I mean by this? LaurenR is an R package that makes it easy to create interactive tutorials from R Markdown documents. So if you already have an R Markdown document, your tutorials can include, just like any other R Markdown document, narrative, figure, illustrations, but also code exercises that students can type code in, but also things like multiple choice questions, and you can inject other things like videos or shiny components in there. So this is what a LaurenR document looks like. There's a progress bar on the side telling your students where they are. You can add some narrative so you can actually describe your lesson to them, and then give them some code exercise where they can actually run the code on the spot, and you can give it like one of these faded example fill in the blank exercises. Grade This is also an R package, and it is a companion to the LaurenR package to actually provide meaningful feedback. And using this package, you can grade the code the students write. You can grade it based on certain conditions. Does it fit it? Or you can actually just grade the result as well. So I'm going to go ahead and give you a very brief demo of this. So this is that LaurenR document. It's a data set about Nobel laureates. And let's say we start with some introduction for our students that they need to learn about their learning goals. They load a package. So here's an example where they don't actually have to do anything. They're kind of just running the code. They load their data set that you gave them. But then as we go forward, maybe they take a look at the output of take a glimpse at their data, and then actually have to answer a quiz question. How many observations and how many variables are in the data set? If they give the wrong answer, you can give them a custom message, allow them to try again, and if they give the right answer, they can happily move forward. They can also do code exercises like this, as I said. So I'm going to cheat for a second and copy the solution. You can hide that if you want. And we can actually run our code. And if they submit the code, they can actually get some sort of positive feedback. I would ignore this yellow block for now. We can get back to that later if you want. That's more of a bug than anything. And also, when they actually write code, for example, how many Nobel laureates fit this criteria for the data set that you had just subsetted, it says how many Nobel laureates fit the criteria, but let's say that the student assumes they need to find the number of columns as opposed to the number of rows, and they run their code and then submit their answer. Depending on their answer, you can actually predefine some potential feedback for them because you probably know what mistake they made. And if they then ultimately get the right answer and run their code and submit it, they can happily move on their way. So how do we actually set something like this up? This is basically an R Markdown document. If you've seen an R Markdown document, this bit, this YAML bit on top probably is familiar to you. But what we're saying is we're going to actually use grade this to this package called grade this to do our checking of our code. And you can see that in our Markdown document, I have the same narrative and whatnot, but I'm going to scroll down to one of these exercises here. This is what the students were seeing. That was the faded, kind of the fill in the blanks exercise. I can provide a solution, and I can say using that grade this function, if their solution actually matches what they have written, we can say you've successfully filtered the data. As you can imagine, I would probably want to go into a bit more detail about what if they went wrong, and in many ways that they may have gone wrong. So the more flexible you want your feedback to be, the more work you are going to have to do on your end. But ultimately, that whole thing is a single R Markdown document that is deployed on a Shiny server that's running for your students. Another option is using our Markdown and GitHub Actions. So very quickly, and our Markdown document is basically a computational document that has both the code and the narrative on the input side. But when you compile it on the output, you get both the code and the narrative, but also the output as well. So everything lives in one place. And GitHub is an online repository for version-controlled documents. And basically, your students, instead of using a learning management system, can use this to kind of submit their work. Why might they want to do that? Because that's what they would be doing potentially in a research environment or in an industry environment as well. So it is not an LMS alternative per se. We're just using it as such. So that students are getting used to using a tool that's used by other scientists and industry professionals as well. And GitHub Actions is basically a cause and effect automation tool for orchestrating workflows based on any event. So if a student pushes their work to a repo or deadline passes, you're telling GitHub, now do this. Let's give this sort of feedback to our student. So our workflow is that each assignment is a private repository on GitHub. The instructor creates it with appropriate permission to the students. At the beginning, the instructor puts a template or Markdown document in there and says, this is where you're going to do your homework, gives GitHub the instructions of the checks that should be run, and then a badge to inform the students of the status of these checks. And the students get feedback as they work on the assignment, if you like, or you can set it to be after the deadline as well. So I'd like to go ahead and quickly show you the an example of this as well. This is what the repository that the students are working in looks like. They have their homework, that Nobel laureates document that they wrote up and actually submitted to GitHub. We can also see the rendered document that they have. This is basically their work. So if you want to read it, you can read this here. But how can we actually give them some automated feedback? So I'm going to show you two things, and then I'm going to briefly show you how. The first one is, remember that nitty-gritty feedback I was trying to give about the visualization about code styling? That's the sort of thing that we can really delegate to machinery as opposed to humans. So we can rig up GitHub Actions to say every time the student pushes their work, let's open a pull request for them and actually show them the results of running a styler on their document. So for example, they have extraneous white spaces. They haven't used the assignment operator. They don't have things like line breaks or spaces around commas. This is all, you know, it's an opinionated, following an opinionated style guide. But if you want to give this sort of feedback to your students, it's incredibly tedious for a human to do that. We can also check to see, do their work actually even compile? So every time they push to their repository, these this action runs. And if you're seeing this green check mark here, it basically says that yes, the document actually knits. So it's taking their Markdown document and knitting it in a separate Docker container in a new environment. And if the answer is yes, the student sees a badge here saying, okay, I know that what I am turning in is going to work for my professor as well. And in order to do this, what we basically have are these YAML files that give some instructions to GitHub in terms of what actions we wanted to take. This sort of a file might be unfamiliar to you, but we have developed some examples of some of the actions that you might want to run. And it is really kind of you can kind of mix and match your own steps for it. And the idea ultimately is to tell GitHub, whenever the student pushes, I want you to do all of these things. And ultimately what it's doing, this should be something that you might be familiar with. We're going to run a function from a package called ghclass to style their repos, for example. All right, I'll hand it over to Tiffany now.
All right, thank you, Mine. I'm gonna start sharing my screen. So hopefully everyone can see a screen that says Jupyter nbgrader. I see Mine nodding along, so I assume so. Okay, great. So I'm going to talk now about two tools, Jupyter and nbgrader, that I have used in the data science classroom for both lower level undergraduate classes, as well as in a professional Masters of Data Science classroom at the University of British Columbia in Vancouver, BC. So the first thing that I'm going to introduce is what is Jupyter, just in case it's unfamiliar to some of you. So Jupyter is a web platform for creating web-based platform for creating reproducible reports, very similar to our Markdown documents. Sometimes we call these literate code documents. They can have both this sort of narrative, which is formatted Markdown, as well as code chunks, and then you can see the code output in line. They're very similar to our Markdown documents, but I would say that in some aspects, they're a little bit simpler from the student perspective because you don't have two documents to manage. So in our Markdown, you have the R Markdown source, and then you have the rendered file, whether it's a Markdown document or a PDF. Here you have both your rendered Markdown and your code output, as well as your code here in one document. They are not as, I'd say, like when you get into advanced reporting, they might not be as advanced as our Markdown tool, but for this entry level, getting onto data science and statistics, they can be a very nice teaching tool. Similar to our Markdown, Jupyter supports multiple programming languages. So I use it in the classroom with both R and the Python programming language, but it can be used for tens of other languages as well. So what we do in these documents, so we've used them as electronic worksheets during lectures in a flipped classroom. We've used them as to host problem sets for our tutorials and our labs is we usually give some sort of, as I showed in the previous slide, some sort of narrative. And then we have instructions and a code block that they're supposed to fill in. And the students will run their code. And then we have these test cells below. We give the students instructions to run this to check their work. And so here's a simple example of one sort of thing that might go wrong for a student. So they're having to rearrange some starter code that we gave them to make a ggplot, and they've accidentally missed including or accidentally deleted the plus operator to link these two layers between the ggplot. This results in a poorly formatted access label and some extra code bits that normally wouldn't be outputted. A new student might not notice these things or think they're a big deal, and might move on before they realize that their plot isn't what we exactly want it to be. So when they run this test cell, we give them a helpful hint that points them to the access label being an issue and it's going to affect their grade. So they might want to go back and look at the code and see if they can make these tests pass. When they do find that adding the plus symbol fixes the code, it looks better to their eyeballs, but then also we have this very obvious success message that pops out that tells them that they are done with this question and then they can move on to the next one. In addition to giving this automated feedback, which the students report overwhelmingly that they enjoy and help them complete their assignments in an efficient and effective way, and they say it also helps how they feel about their learning, we can layer on another tool to Jupyter called nbgrader, and this allows us to do auto grading and keep track of the students across within an assignment and across multiple assignments. So here's a little, it has both a graphical user interface and a command line tool, and we end up using both to make this tool scalable to our larger classes. So here's a very small class with 3 students, and this is after the auto grading for their worksheet has been run, and you can see that this student got 3 out of 6, the student got 5 out of 6, and the student got 6 out of 6. This data is stored in a SQLite database, but it also has a little export tool that will let you to output it to a very usable, readable CSV output that then you can use. We use, for example, Canvas in our in some of our classes, and we have like a GitHub LMS and in some of our other classes. And so we use the APIs for these tools to send the data from our CSV out to there. In addition to keeping track of the student grades, nbgrader also has a really nice feature that the students really enjoy, which are these feedback forms that can be automatically generated as well. So these feedback forms are HTML documents rendered from the students' auto-graded work that we collect. And what happens at the beginning is that you have this nice little table of contents that gets added to the document at the top with hyperlinks, and it tells the score that they got on each of the graded questions. So if the student says, I didn't do very well on question 7, they can click on the hyperlink here. It will navigate them down to that part of the of the Jupyter Notebook document, and the student's able to see their answer, see the grade that they were given, and if the instructor really wanted to, you could go in and individually provide comments and manual feedback to the students. nbgrader also has the capability for doing manual grading. That's beyond the scope of this talk here, but just know that this tool can let you do both things if you want. And you can override the auto grading if you need to as well. Okay, so at this point, I'm going to move from the slide deck into the demo that I have for Jupyter with nbgrader with R. So first I'm going to show you what it feels like for the student. Then I'm going to show you some things that the instructor will have to interact with and what that looks like. And then finally, this will be all done in R first. I'll show you a student document in Python just to show you that the look and feel is the same. So this is what would look like to the students. Somehow I can talk about this later in the Q&A session. Somehow you get the document to the students. There's various ways that they can interact with it, either through a web-based server or they run it locally on their laptop. And we have some questions. I'm going to skip down to the analyzing data with R. We have some instructions. They have to run a test cell to, a cell to set up the automated feedback, which is really an R script that has a collection of tests. And then here they answer a question where they need to use the library function to load a variety of packages. So here they're going to load the readr package. And then if they forget to load the other 3 packages, they run this test cell, and then they get some feedback that their solution is incorrect. The dplyr package also needs to be loaded. Try doing this with the library function. So I hopefully have the correct answer loaded in my clipboard. So they load the libraries, and then they will scroll down to run the test cell again, and then they get that success message. So then they know that they can move on to the next question, which is reading about the data set and then loading the data set. Oh, sorry, here's a multiple choice question, and later they'll load the data set into R. So that's what it looks like from the student's perspective. How does this work for the instructor? So the instructor, you are setting up, there's a specific file and directory structure, which I won't go into, for setting this up for your students, but all of your answers and solutions are created in this source directory, which I have an example open here. And this is what it looks like for the student. So let me, scroll down to, so this is the instructor. So you write the solutions in here, and you have to surround it with this begin solution and end solution flags. And there is some automated tools with nbgrader that will, after you've created your student version, your solution version, will suck and remove all of these out of it for you. You also have this metadata that says that you have to use to tag the cells as auto-graded answers. These are the auto-graded tests, and set what the point values are worth for each question. We keep our tests in a separate file, and I'll talk about the rationale for why in just a couple minutes. And so that's what it looks like from the instructor perspective. And then this is the graphical user interface that the instructor uses, where you see the worksheet that we're working on here. You can click this generate button here, which will automatically take that instructor version and create the student version for you. And then once you have that all set up, you can go into manage students and run the auto grading from here. If you have a lot of students to grade, you probably want to move to the command line interface to do large batch grading. The worksheets in Python look virtually identical. The only thing that is changing is the code that you're writing. So you change the kernel that you're running in the Jupyter Notebook, you change the code you're asking the students to write, and you change the code of the test that you're asking the students to write. So I'm going to flip back to the slides now. I'm going to go, I should have been in full screen before, and talk a little bit about best practices so that we have some time for questions. So we've done this for several years in the, at UBC and in the Master of Data Science program and in the undergrad courses. And so we've learned some things through mistakes, and we'd like to share them with you so that you don't make the mistakes yourself. The first is to measure twice and cut once. So you really need to verify the correctness of your tests. It can almost be more of a harm than helpful, including tests that are incorrect, because if the student has the correct answer, but the test is saying that it's not right, that can be very problematic for the students. The second is that we want to write robust tests. So there can be multiple correct ways oftentimes to get a solution, and you don't want to write tests that only say that the student is correct if they got it in a very specific way. And also, you want your test to be robust between different versions of software. So we do things like round answers, make sure that we're saying something is numeric, or that it's a float, or that it's an integer, for example. And I didn't mention it here, but also with strings, you want to like put everything in uppercase or everything in lowercase, and those sorts of things to make sure that if the students get there at a different way, or if software version changes slightly, your tests are still going to work. The third is that these tests are visible to the students. That kind of has to be this way for how this platform operates. And so, but sometimes you don't want them to see the answer, because then that they could use it not the correct way, or not a meaningful way to give you that answer. And so we use a tool called hashing to hide the solutions, and then we hash the students' answers and see if the hashes match. Next thing that you want to think about is you want to test your tests on the student's compute environment. So you're developing maybe on your laptop, but before you hand out your work to the students, you want to make sure that they're running, that your tests are going to work on whatever computer they're using it, whether it's a server-based solution or their laptop. Server-based, you can maybe deal with this by developing your stuff there, and then you know the students are going to work there. If everyone's working on their own laptop, for example, then maybe you need to give some very specific installation instructions to your students. The fourth is that, or I guess the fifth is that we found it very useful to abstract our test to a script that is sourced or imported into the student's Jupyter notebook, as opposed to putting the tests in there. And that's because sometimes we do make mistakes, there will be bugs, we are human. And so it's with Git, it's very easy to change this other file that the students are never editing versus changing a file that they're continually editing and updating. And the last point I think is a really important one is that you don't want to give automated feedback on everything. In the real world, when you write code, there are no tests given to you by other people generally, or maybe eventually you start writing your own tests, but you have to be able to decide when the code is correct yourself. So we use hidden tests at later stages in the assignment, so the students do get some practice deciding that they are done without this feedback. I think this is one from Mine that she has added here. So she also says, consider peer feedback when automated feedback is not feasible. So yeah, we've talked a lot about feedback from like a coding perspective, but yeah, the interpretation and narrative beyond multiple choice and true and false, you do need to, if you want to scale that, and TAs can't, we can't scale our humans with the class enrollment sizes, then using peer grading can be an effective resource. So here we've listed some resources for you if you're interested in learning more, and I will stop talking now. Thank you.
Great. Well, thank you, Mine and Tiffany, for really covering a lot of ground in a short amount of time. Having the link to your slides is really helpful. That's also in the chat window for people who want to kind of follow along in some other ways. The theme of eCOTS this year is engaging everyone, and you've done that in spades, and also talked about ways to do it at scale. There are a couple of questions I'd love to kind of add in here. One is, do you have any examples to share of kind of assessments or LaurenR or other kind of nbgrader things you've done that people could look at as they start to build their own?
Yeah, so the resources slide has links out to LaurenR examples, GitHub Actions examples, and Jupyter nbgrader examples that have been used in class. And those would be, and each of those have the source code available, so folks can dig in and actually start, grabbing pieces as well.
Obviously, there's different systems you've described here, but the question came up is, are the comments that students see on submitting an incorrect answer, are they customizable based on what they submit?
Yeah, absolutely. In the nbgrader case, what message they get back from the tests is up to the instructor to write. So your feedback is going to be as good as you make it, and it gets better the more users have interacted with it. So you can't predict all the ways the students are going to give you an incorrect answer. And so the more times you see that kind of interacting with the students in the classroom, that will give you insight into how to write your feedback for the students.
Great. There's also a question on the LaurenR system. Can you collect scores on how the students are doing on their LaurenR assignments?
So yes, and not trivial would be my answer. So there are a batch of slides at the end of the slide deck that are like FAQs, and that was one of them. So there's actually a package that Danny Kaplan is working on that is for recording events with LaurenR. There's also the group, like the folks at RStudio who are working on developing the package are doing so as well. So it is certainly rigged up to do that, but currently if you wanted to do that, you're going to need to like dig in a little bit. But I did want to very quickly mention that there is a very cheap hack that you can do. This is not, if you're not grading them, one thing I've done is I've embedded like a Google form or a Microsoft form at the very end of it, and students click on that and authenticate, and so I at least know that they have done it. So if you're grading just for having done it, it works. And then you can actually collect some text data from them on like a 1-minute paper type reflection, and I've found those to be incredibly helpful for figuring out what students may be struggling with.
Great. Well, again, thank you, Tiffany and Mine, for a wonderful presentation.